Greetings, celestial classifiers! Astronaut B here, ready to embark on a voyage of discovery and understanding. Today, we're venturing into the vast realms of classification, a journey that requires us to sort and understand patterns based on an item's attributes. Let's unravel the enigmatic concepts of unknowns in our data, set precise thresholds, navigate through vast data sets, sort in specific categories, and employ the marvels of artificial intelligence and machine learning to make our tasks easier. With the cosmos as our canvas, we'll unveil the secrets of classification, ensuring every space rock finds its place amid the stars. So fasten your space belts. It's time to classify the universe. Imagine holding 3 gleaming space stones from a new galaxy. For these rocks, 3 attributes are used to determine the type of stone: size, luminosity or brightness, and mineral count. These descriptive categories that are used in classification are also known as attributes, and they will help us to classify each stone into a category. Our goal is to create a data set, which is a collection of related information. Lucky for us, we know from previous experience that the 3 stones we have are Pyrox stones. In order to write a program that will easily identify all future stones of this type, we will need to identify the thresholds of each attribute. Thresholds are the minimum and maximum values that an attribute can be in order to be contained within a certain category. With our 3 Pyrox samples in hand, we can now determine their minimum and maximum values for each attribute and document these in a chart. Let's start by scanning the first category, size. It seems as if the smallest size is 3 centimeters and the largest size is 5 centimeters. We can record these in a new chart. Next, let's look at luminosity. What are the minimum and maximum values here? That's right, 65% is the minimum and 75% is the maximum. Lastly, we have mineral count. Can you finish the chart? Take a moment to complete it on your guided notes sheet. Great! 18 is our minimum and 21 is our maximum. Great job! We now have a data set that categorizes Pyrox stones. Now that we've deciphered the Pyrox stone's attributes, it's time to cast our net wider. Let's look at multiple stone types that we've collected from our travels and create a comprehensive data set. For each stone type, we would go through the same process, taking samples and finding the thresholds of each of the attributes. We're not going to do the process again for each stone, so instead, I've already come up with the finished product. Now, we have a classification guide that will help us write a program to identify any of the 3 types of stones. Equipped with our comprehensive galactic gem chart, it's time to develop if statements that will seamlessly classify any stone we encounter in the cosmos. Using our chart, how can we develop an if statement that can determine if our stone is a Pyrox stone? Right! We will use the AND logical operator to combine all of the conditions for the stone to be a Pyrox stone. If all of these conditions are true, we found our stone type. Can you create ELIF statements for galaxite and stellarnite stones? Take a few moments to do that. Great job creating all of those conditional statements. Does your if statement match mine? Take a moment and pause the video to make sure. Now for the fun part. We get to test them out. Below, I have data on an unknown stone. Let's use our program to classify it. The size is 5, the luminosity is 50%, and there are 11 minerals. Take a moment and see if you can classify the stone. If you said galaxite stone, you are correct. You're great at classifying data. Let's try a trickier one. The size is 4, the luminosity is 25%, and there are 90 minerals. If we have these properties, in what category will it be classified? Uh-oh, this one doesn't fit any of our categories. This stone may be a new stone that we haven't classified yet, or one of our categories may not have enough data and needs to be expanded. For now, anything that doesn't fit into our predefined if statements will be categorized as unknown. We can add an else statement to the end in order to catch any pesky unknowns that don't fit into our current categories. Let's use what we've learned to complete the task, Asteroid Classification 1. In this task, we will get to operate a space telescope and use attributes such as brightness to write if statements to determine the difference between rockets and asteroids. By clicking on each example tab, we can see different brightness values for each object. Using the methods we have discussed, you'll write if statements that determine if an object is an asteroid or a rocket. When you're fairly certain you've identified a rocket, call upon the rocket function. If, on the other hand, an asteroid seems to be in view, invoke the asteroid function. And there we have it, intrepid explorers of the universe! We now have a basic understanding of how classification, or the sorting of items based on their attributes, works in computer science. We've journeyed through data sets, identifying collections of related information. By setting thresholds, the boundaries that define our items, we were able to create if statements to determine what category our item could be sorted into. Also, we've discovered unknowns, those items that don't quite fit into our classification ranges. The tools of artificial intelligence and machine learning have been our allies, making sense of the vastness that surrounds us. As we wrap up today, always remember the power of classification. It's more than just sorting. It's about understanding, predicting, and shaping our understanding of the universe. Be sure to complete the programming tasks, practice questions, and extension activities before moving on to the next lesson. And remember, in the universe of coding, the possibilities are infinite. I'll see you next time.